Okay, good afternoon, everyone. I hope everybody can see me. You can see my screen. We'll start in a bit. There's still a few people jumping in on the call. Apologies for the slight delay. So yeah, I'll just give a quick introduction first, and I'll hand over to part 2 of our webinar today. So quick introduction again. So my name is Geberit International. I am the SoPHE UAE chair. And the webinar today will be on acoustic design for acoustically optimized building, module 2. It's kind of a continuation for where we left it yesterday. So if I may jump on the next slide, I won't talk too much about SoPHE today. So we'll go straight into the presentation. So again, the technical presentation is on acoustic design for acoustically optimized building. Hosted and presented kindly by Geberit, and the speakers is Mr. Vinay Kumar and Mathias Riggenbach. So a few session notes, please type your question on the Q&A panel. They will be answered by the speaker during the Q&A session. Your camera will be off and mic will be mute. Please note that this webinar is being recorded. We're going to share the recording on the CIBSE UAE YouTube channel. And as well, this is CPD accredited. So anybody who registered, we're going to get your CPD certificate as part of this webinar. So today we're going to kickstart on module 2, which is acoustic regulation. We're going to cover acoustic standards, acoustic data, and follow up by live Q&A session. So on this note, I'll hand over to Vinay.
Yeah, thank you so much, Mr. Giovanni. And yeah, I would like to welcome all of our customers today to be a part of this module 2 after being very successful module 1, where we had like nice overview of description and detailing of acoustics sound level for our bathroom layout and also the built-in drainage system. So today we will talk more about it in terms of in terms of regulation standards. I'll just share my screen to the person who who is new for this, just to share the company introduction. Yeah. So Geberit is well-known company worldwide. We are a European market leader in sanitary products. We have a global presence worldwide, and we have a powerful brand like Typhoid, Colo. So we have all range of bathroom products inside, like behind the wall and in front of wall. We believe in successful business model, which is like push and pull principle. So we learn also from market, and by learning and adopting the things or the feedback from the customers, we develop our products in such a way like that will be good for the social life, so that people can have a luxury thing with our product range. Little bit about key figures. We are doing quite good, 3.1 million of sales, and we have an organization in more than 50 countries with 12,000 employees. We have production plants of 29, majorly are located in Europe, and 6 or some around, if I would say 6 or 7 are located in other part of the world. So I'll take a little bit time for this Geberit history. So we are like having more than 100 years old experience. As here we can see, our company is founded by this gentleman in 1874. Then we are the inventor of first wooden cistern in 1905, then plastic cistern. Then we had development on drainage system in the year 1956. Then if you see, after that we had a lot of other developments for water supply, installation systems, shower details, map race, monolith, bathroom, like in front of wall basically. And then I would like to show you the strategy part where we invest is 10 technology area, what we see over the screen. So today our topic is basically on statics and sound installation. So I would say Geberit is investing 3% of annual turnover to the engineering department, and there we develop our products in terms of hydraulics, hygiene, statics, fire protection, virtual engineering, material science, etc. So today we will see, again, as we discussed, more things on regulation part about statics and sound insulation, so we can get the actual value, how much it should be for our bathroom in practical scenario. Sound lab, what we have is nearby our factory in Switzerland, which is like from more than 20 years old. And here we have all the setup where we can get the actual value from our industry, so that we can believe in the real value on acoustics. So with this, I would like to hand over to our next speaker, Mr. Mathias. He will share us more and more ideas about this regulation. Over to you, Mr. Mathias.
Excellent. Thank you for the nice introduction, Vinit. As Vinit already said, we will start right away with the topics and go on with the acoustic regulations. And I see also participants, we have some new ones, I guess, but also some people who participated already yesterday. So just a short recap for the new ones. Yesterday we spoke more a bit about the basics of the acoustics and the importance of design. So design is very important when it comes to acoustics. Already there you can do a lot. And if you have a good design, maybe regulations are not important if you are going with the pipe through rooms which are not in any acoustic standard. So you don't have to actually adjust any rule to those ones. And if you do this one right, then you have done already a big part of the acoustics. And then, of course, also installation. This is actually where most of the mistakes are happening. So even if you have a good layout, if you have a good product, if you install it wrong, as every other product as well, then of course you will not have the values which maybe you initially have defined. So those are the most important parts, even before you talk about acoustic regulations. So do a proper design, make a proper installation, and then let's say the big part is set then to talk about the regulations. Okay, so then we start with first of all with the responsibility. Who actually has the responsibility for the acoustics in a project? So of course the architect, and that's why I mentioned again in the layout and the design. So he's the first one who puts the design, who puts the layout. So he has a big influence on how the solution is going to look in the end. If we can have, we can make our life quite easy, or also it can make our life even impossible. If the design or the layout is done in a very complicated way, it will be very difficult to achieve good acoustics. Maybe you remember the slide from yesterday when you have, for example, as you have unfortunately much in your region, cross-floor installation, then it will be very hard to achieve some good values. It's possible, but in this case also very expensive. Then also the planner, of course, definition of the installation walls. Do we go with solid walls? Do they choose dry walls, which are of course also better for acoustic installation? On some projects, we have even sound specialists, so they consider the full building aspect, of course, not only the pipes, but we see, depending a bit on the region, there are more and more also sound specialists involved, depending also on the size of the project. And then, of course, the installer for the practical implementation on the construction side. So if, let's say, everything was done well before, and he does a good installation, then and only then we can make sure we can meet the requirements of whatever regulation we aim for. And therefore also you see it's crucial for us to know what are the exact sound insulation requirements of the client, so mostly the owner or the developer. Maybe he already gives an indication to the architect or to the planner, and this should be done in a written way. So a DB level, DBA level should be agreed, maybe even a standard should be agreed on which you want to build up the building. Because also, as I said, this will be our first question. When you have acoustic requirement, we will ask you first, okay, what level you would like to achieve? Is it 30, 35 dBA, whatsoever? Which standard are you going to use? And then, of course, we can also give you good support. So when I come to standards, I showed yesterday already, we had different standards in place. So we have in Germany, I would say this is together with the Swiss standard, the most exact and advanced standard when it comes to acoustics on piping system. Of course, the one in Austria also, it's quite similar to the German one. Then we have British standard. I will also show there are some standards in your region which are referring to BS 8233. There, unfortunately, we also have a bit of a challenge in the UK with this standard. We think it's not a complete standard. We have some standards in Israel, and then very important, we also have this DIN EN 14366, and this standard specifies a process where rainwater installations can be measured under unrealistic laboratory conditions. And this I will explain you further. And this is also many times a challenge for us that those it's not a regulation, it's actually a test. It's not a regulation or a standard which shows acoustics. It's just a test with pipings, with the piping build-up, which is done in the Fraunhofer Institute, a very good institute, by the way, well-renowned in Germany. But it's a predefined situation which is not reflecting the reality in any region in the world. But I will come to that later. But this is very important. The both ones, they define acoustic values within buildings, and the other one, they are just measuring only pipes. And already yesterday we spoke always about the system. We always speak about the full system, which should be floating in the building, and not only about a pipe. So you have to consider the full installation. Okay, so when we look at the first thing from Dubai Municipality, from the Green Building Regulation, you see here it's already referring mainly to BS 8233. So what is written in those standards refers, of course, to the UK sound insulation and noise reduction for building code. And the same is with the newest Dubai Building Code Part H, indoor environment. I think all of you knows this standard. It's quite, it's from 2021. And there also we have in the H10, we have acoustics. And also here you can see mostly it's referred to BS 8233. So that's why I will refer to this standard and mainly talk about the BS 8233. As you are referring to this standard, and you see we have here defined levels for different times. So from 7 to 11 o'clock and 11 to 7 o'clock in the morning. And you see already the values, they are between 35 and 40. So I would say in average on international standard, this is rather high. But also this is here you see for steady external noise sources, it is desirable that the internal ambient noise level does not exceed the guidelines from table 4, and this is this table. So this is, as you see, mostly for external noise. What do they write in Annex H? The recommendation for ambient noise in hotel bedrooms are similar to those for living accommodation. So also there, what means similar? That's not very detailed described, and can lead, of course, to confusion if you make a building or if you make a hotel bedroom. So what means similar? Does it mean 30? Does it mean 33? So this is not clearly specified. And in the end, also we have on H4, noise emission from hydraulic systems, including domestic hot and cold water services, pipe work, soil and waste pipes serving bedrooms is not to cause disturbance in normal use. So what does that mean? Is it 45? Is it 31? Is it 25? Nobody actually knows. And that's why also the British standard, I would say, if you refer to British standard, it would be good maybe for other things outside noise sources, whatever, which is defined. But for pipe work, soil and waste pipes, and so on, this standard is unfortunately not very suitable in our point of view. So there's no baseline figure for the sound pressure of water and drainage passing through pipe system in UK. So no minimum standards for architects and consultants to be met. And this is what I say, if you have complaints, when we talk about psychoacoustic, this is very important to have a number defined. If you are above, then you have a problem. If you are below, maybe customer still is not happy, but you have done your job well, and then you have fulfilled your task like in any other discipline where you have defined standards. Even if customer is not happy, if you meet the standard, then everybody is happy. When we look then at DIN 4109, we have actually 41091 and 5. And the difference is just the minimum requirements you have to meet in every building, so without any special contract in Germany. And then also you have increased requirements for high quality buildings, which you can agree on. And then say, okay, I need increased requirements for my building, and this is of course also possible. But mostly the minimum requirements are used. You see also the rooms in need of protection here against noise. This is also described. Living spaces include hallways, eat-in kitchen, bedrooms, bedrooms in hospitals, sanatoriums, office spaces, and so on and so on. And then in the 41095, additionally, we have residential buildings and buildings with living and working areas, hotels, lodging establishments, and hospitals and sanatoriums. So this is also additional requirement from the standard. And as I described here, of course, there is it's not an ideal situation because you have the neighbor living room. So you see here living spaces, and then here you see when you have the bathroom and the kitchen, there's no disturbance from one to the other room. With eat-in kitchens, they mean if the kitchen would be open, of course, to the living room, then it would be different. But mostly the kitchens are closed in another space. So in this scenario, we will not have to meet any criteria I'm going to show you. You can make your installation, and the criteria would only value for the room which is far away. So when we look at the standard 41091, so you see diagonally in the vulnerable room located diagonally below in foreign area, so not in your area. We have for living spaces and bedrooms, you have the 30 dBA, and in classroom and office spaces, we have 35 dBA. So clearly defined, everything clear. Also measurements are described, how you have to measure that after the installation, so you can verify that those values are met. And then for the Asian vulnerable room in your own area, of course, there are no requirements for your own area, as this is not considered in the standard that you should not get disturbed by yourself. When we look at 41095, we have the same actually scenario, but the values, as I said, it's the higher protection are 3 and 10 decibel lower, and this is also the same for diagonally and also the Asian room, vulnerable room in your own area. So those values are fixed. They have to keep these values, and if there's any let's say if you are over those values, as I said, you have to open the walls, you have to check what is wrong, and this is quite or can be quite expensive, as at this stage people are already living in the building. So very important that from the outset you make a clear definition what you want to plan, the dBA level, and then make sure the installation is done well. So this is to DN 4109. And then also here, the 14366, which we also see in new region, is many times used by different suppliers. And also it is said here, even from the standard does not provide a standardized procedure to calculate the acoustic properties of such an installation in building, and also that some measurements which were done before 2014, they are not valid anymore due to some, let's say, unreal testings which were done on the setup in the institute. So how it looks, what is the difference to the two standards? You see here the build-up of EN 4366, and then we have the build-up according 4109. So these actually are the build-ups we do in our laboratory here in Rapperswil. So we build up the full bathroom here, and then we flush always a realistic flush through the toilet, which we all know is the most loud device. And you see here complete sanitary installation, and in the EN 14366 they measure always with the discharge pipe without WCs or additional sanitary installation, and also they have a constant flow with different flow rates. Of course they also then get different values, but this is a constant flow. And the measuring, you see when they measure here, the feed-in of the water is 2 floors about the measuring. So this diagonal here, this diagonal measuring, which is considered in the standard, is not reflected in this standard. What we do here in our laboratory here, we always have the room diagonally above. Of course, we measure all the rooms around, and this, of course, is a realistic measurement which applies to a real building site. So that's here you see supply feed 1 story above the measuring location via operation of toilet flush, and here controlled supply feed 2 stories above the measuring location. Then also the supply feed flow. So also here they go up to 2 liters per second, 4 liters, 6 or 8 liters per second with a constant laminar water flow, and then they start to measure. And we, of course, when you flush a toilet, you always have a turbulent flow caused by the operation of the toilet flush. So we already know that most of the noise are generated here within these fittings when you have the branch pipes, when we hit the walls of the branch pipes. And then here only you measure a straight pipe which comes in and measured only 2 floors below. So also the results are not like a realistic build-up. Then also what we see in those reports, they use mostly this very expensive pipe bracket. So it's called Bismuth 1000. And this is a pipe bracket which one bracket costs up to $20. And this is tested when they do the standard test. But in reality, also price-wise in the building site, I've never seen that this is applied. And of course also price-wise, that would explode the costs. Of course, it's a very good bracket. It would make sense to use it, but due to cost in value engineering, mostly that's the first thing. It's most of the time not even there, or this is the first thing they put out. On our system, we have system brackets. You have to put them in. We are very strict on that. I said also we go on the buildings. We help you in the installation. If the contractors are not using the right material, of course, we are not approving the systems and they have to change it, as we can then not guarantee the sound values which were defined before. Then also measuring location. So as I said, 2 stories below the supply feed in a diagonal room underneath. And here we are just here in the diagonal room where we have the microphones. By the way, there are 3 microphones always in the room at different heights. So also this is clearly defined how you have to measure this. It's not just with a mobile phone, whatever. So this is already a very professional setup, which we have in our sound laboratory. Also, of course, they have it here on the EN 14366, but 2 stories above and without any bends involved. Then also very important, the wall construction. Here you see the thickness of the wall has a basis weight of 220 kilogram per square meter. This is even not reality when we look at the installations in Germany, for example. But even in other regions, we are far below 200 kilograms per square meter. And this, of course, has a big influence, the mass of the building, not only for airborne sound, but also for solid-borne sound, how the sound is transported to the other floors. And that's why we think this measuring is not realistic, and in the end doesn't give you a real figure which you can use in your real case on the building side or on your building afterwards. Again, also the fully sound decoupled cellar. Here you see the cellar is fully sound decoupled, and also here we just use a realistic installation with the brackets, where the cellar is just normally installed, and then also the noise which comes up from here is considered. So this is just to explain you the reality, the facts, how this one is done. This was not invented by any company. That's just reality. And most of the suppliers, they measure, of course, this here. And we, as we have our sound laboratory, we measure, of course, the real situation, because afterwards on the building side, we also guarantee the values within the standards, so which are between 30 or 35 dBA. So what is the difference here? You see on the laboratory conditions, so it's established methods for measuring sound rising, and this is also more for the suppliers for measuring maybe the different pipes and see what are the differences between acoustic and non-acoustic pipes, and not actually for the end customer or the end installation. There we always have to consider systems. And also the standard does not provide any methods for calculating the acoustic characteristics of a building's facilities. Of course, also there we have quite many experience with different setups, with different buildings, which we measured in our laboratory, as we have measured many different situations with different walls, with brick walls, with gypsum walls, and so on and so on. And in the EN standard, they always have the same build up with the same walls. So of course, there also it's limited. So you see here, it's strict defined limit values for the maximum sound level of technical building systems, guaranteeing high level of living comfort. And also the standard does not make any specifications in terms of structure. For this reason, only sound measurements taken under realistic conditions are suitable for demonstrating the required sound insulation. And very important, when we do sound measurements, of course, we also do it together with the Fraunhofer Institute. The only difference is we build up everything in our laboratory, and then we invite the Fraunhofer Institute to come to our laboratory. They are verifying everything, and then also on our measurements, we get the stamp from the Fraunhofer Institute. So also we work closely together with them, but our approach is different. As we have a sound lab, and we do in Germany, Switzerland, Austria, we do a lot of acoustic installation, and we have to make sure that our system are 100% fitting the values when the customer will do measurements. So here you see EN 4366 is a cost-effective way for keeping customer happy, but not giving them practical values, which can be applied in daily work. So they give rough values of unrealistic installation. And here with the laboratory, with the people which are working in the laboratory, with all the build-ups, you have to imagine such a build-up costs from 50 to 100,000 Swiss franc, or also the approvals when Fraunhofer Institute is coming to verify that. It costs a lot of money, but this will give us practical values, which for you as customer are very important, because in the end, you measure in your building the value, and you want to make sure you achieve for example, the 30 dBA in your own building. So, conclusion of standards. In the end, we do not mind which standard or acoustic level has to be considered in a specific country or building site. So this would be up to the customer to define this. But of course, to help you, for us, it's important to know. But what you are choosing for us, this is not important. We just need a value that we can give you a good solution. And also, the customers, they have to apply country-specific acoustic rules if they are available. Mostly they are not available, or as I showed you, maybe not so precise. So then, of course, you can define by yourself or say, okay, I would like to go according to German rules, Swiss rules, whatever rules you consider, or even define only a value which you would like to reach in your building. If nothing is defined, actually nobody can complain. We have this case many times. They maybe come back and say it's too loud, we are not happy, whatever. What can we do? And as I said, first question, what was defined before? Yeah, nothing. Okay, what would you like to achieve? I don't know. Okay, how loud it is? I don't know. It's just too loud. So first thing we would do a measurement, and then of course also define what should be the appropriate value to achieve. And also, if sound measurements are executed on building sites, Geberit can deliver the best available data within the sanitary industry. I think that's also important. We have the realistic values which are measured in our laboratory and which are also reflecting the reality. And this is what I would like to show you a bit, how we get the data, and what is a bit the difference between the different build-ups which we can recommend. So acoustic data, that's also here. Unfortunately, I showed already yesterday a picture, and this is also many times the reality. When you look at the build-ups here, you see completely installed pipes touching the walls. Then also here, very complicated installation. Here, combi-fix installation. The pipe is touching directly the walls. Also here, you see there's no rubber on the bracket. And there, of course, the most expensive piping system is not doing any help for the acoustics. Unfortunately, mostly nobody's going to measure. Initially, mostly they are asking for reports, and then this Fraunhofer EN 14366 reports are shown. Even values below 20 dBA, sometimes value with 12 or even 8 dBA are shown there, and this is not realistic. And also we think in a standard should define a maximum value, and if you are below, then of course, then it's okay. How much you are below doesn't really matter because you are fulfilling the standard. And if one pipe is less than the other, even when the difference is 3 decibels or less, we cannot even hear with the human ear. That's why also you see mostly it's in 5 dBA, the classification. If it's just 1 or 2, 3 dBAs, we cannot even hear the difference. So that's why that's also important to have this differentiation. Then you see here an example with a combi-fix installation. This is a build-up we did in our laboratory here. So typical build-up with combi-fix. And then you see here we have the built-in situation here with the duct. And then you can also see we have a drywall. Everything is specified, Knauf W112. We have a HDP pipe here on the downpipe, and also we have here HDP pipe on the branch pipe. And please pay attention here to the basis weight of the wall. This is 112 kilograms per square meter, so not comparable at all to the 220 kilograms per square meter which we have in the Fraunhofer build-up. So also here you see this is not, as I said already, this is not a desirable value which you won't have. But of course we also tested this to show, okay, what is happening when I do it wrong, or maybe even at sometimes 40 dBA is sufficient, depending on the requirements. And also you see on every statement, we also have the Fraunhofer approval. So they came to our laboratory, they measured the value, and it's all verified. Here we have the second build up with a Duofix installation. So also here with Knauf W112, and already here you see the downpipe is all DB20 pipe, so acoustic pipe, but the branch pipe here, as we have a same floor installation, we can still do with HDP pipe, no problem. There will be no interference to the neighbor which is below. You see the pipe is all above, and like this we can guarantee the 30 dBA in the neighbor's flat, which is diagonally. In the neighbor's bathroom also, if you make a clever build up, you have the bathrooms above, not only for acoustics, also for hydraulics. This makes sense. And then in the neighbor bathroom, there are no air requirements necessary. So what we do, measurement data, we have many measurement data for many common situations, for various real-world situations under realistic conditions, and you see you have it certified also by Fraunhofer certification. This, for example, is one build up with our Duofix system, which I showed you yesterday shortly, and here, as I said, of course, a bit more expensive, but also you will get better values out of this. So I already come to the summary, and I think that's the most important one. Nobody cares about drainage until it becomes a problem, and when it becomes a problem, then it is very difficult to find a solution or very expensive, because when the people are already living in the flat and they are not happy and you haven't defined the value, you have to go all the way back to the initial planning, and then it can get very expensive. That's why designing with acoustics in mind from the outset. So think at the beginning, if you want to consider the acoustic, of course, it makes not sense in every building situations, or in let's say in a factory or something like this. It doesn't make sense to consider acoustics. But if you do, please do it from the outset and make sure all the relevant points like design, material, and also installation are set from the beginning. So here, as I just said, ensure good installation practice. That's important. And then also from our side, if you get the EN 4366 certificate, make sure that you get a signed confirmation of the value if they are measured once the installation is finished. So if you get such a certificate, which is stating 15 or 10 dBA, just make sure that this will be, once everything is installed, you make professional measurements in your room, that you will get these values. And I can guarantee you already that values below 20 dBA, I think they are almost impossible to reach. They are nice to show, nice to communicate, but on a real situation, and as you have seen, it also doesn't make sense. You can reach them, but it would be very expensive. And also very important, as I said, the support for the solutions within the project at the beginning on the design. If we do designs for our projects, we always consider the acoustics, and then also the support for the solutions when it comes for installer training and so on. We can give there a big hand. Okay, so I think that's more or less it, and we could go over to the Q&A session.
Great. Thank you very much for this nice presentation. I think this pretty much gives us some insight in terms of relevant code and standards. So we'll open the floor for Q&A. We've got a few questions from Yogesh. Let's go for the first one. Are you offering installation guidance also to guarantee that NERS criteria are met? I think we did partly cover this question yesterday, Matthias, but if you can elaborate a bit more.
Yeah, maybe I go quickly back to the slide, and this is always let's say a challenge here. That was actually on the first slide I showed. So here actually the guarantee and the guidance, yes, we are giving with all the installation instruction and so on. We also go to building site, but in the end, the guarantee of the values, they have to be given by the architect and the installer. We are, let's say, as a supplier, we are just supplying the material. We realize that this is not enough. We give more guidance. We do support in the region. We have very skilled people like Vinit who can help. But in the end, also we have to say the responsibility is within the architect, the planner, and in the end also the installer, as we are not doing installation. But of course, we give guidance, we help. If you have a building, we come on site and we give, let's say, advice how the installation has to be done. But in the end, the installer is offering the project, and he has to make sure that all the requirements are met in the end.
Okay, thank you. Another question from Yogesh. Is acoustic drainage required within the toilet area if the toilet blocks are stuck in a high-rise building, for instance?
Do you want to answer one, Vinit?
No, I would suggest you to proceed here, Matthias, because this is quite linked to the previous question. Yeah.
Okay, I do that one. No worries. So as far as I understand, when the toilets are blocked or are stacked in a high-rise tower, it doesn't have to do anything with it. So if let's say values and everything we do calculation for, we always assume with a working system. So we are not measuring a non-working system. So this in any standard, this a blockage is let's say I would say is a non-working system, and then this is not considered in the measuring, of course. So then we would have influences which can differ quite widely, and this is not yeah. Anyway, this would be exception. Hopefully, this would be exceptional case, and then also that I think the most little problem you have is the acoustic in this case when you have a blockage.
Yeah, I think from if I get what Yogesh is saying, yeah, with regards to the standard, you mentioned that the criteria, which is like 30 dBA, 35 dBA for living space, bedroom space areas, you know. But if a toilet is stuck on the toilet, within the toilet, because I had it in the past as well, where contractors saying that, guys, this is a toilet, you will really need to specify acoustic drainage or DB20 pipe for the toilet itself. So we end up really in certain instances having kind of an amalgam, kind of a two-pipe system. So normal drainage pipe work within the toilet, just normal plastic pipes sometimes, or HDP, whatever it is, and then acoustically pipe within sensitive areas or habitable space like bedrooms, kitchen, living space, you know.
Okay. Yeah, so this really, yeah, as you said, Giovanni, completely right. It depends always on the location where the pipe goes through and so on. If you have if acoustic pipe is required, but also this is something when we make designs, we have a look at it, and we only specify acoustic pipe where it's really necessary. Yeah, completely right.
All right, fantastic. Next one. In UAE, the standard is to provide floor drains within the wet areas. Do Geberit have acoustically typed floor drains? And do you guys have any test data for the floor drains? Bear in mind that most of the floor drains are pretty much kind of back in that gully. So you kind of discharge a washing basin or a bathtub, etc., to the floor drain itself.
Exactly.
Yes, I think.
Yeah, maybe Vinit, go take it you.
Yeah. No, actually, I would like to just add one input here. Maybe you can also share your thought, Matthias, on this. Yes, what Yogesh is saying is correct, because here in this region, as we know, we have a triple pipe system, and with a flow drain. Like we used to have flow drain. This is, I would say, because of the culture difference. And yeah, when we compare flow drain, then it again depends. The first thing, if you remember, you guys in yesterday's session in module 1, we had seen like the acoustic favorable condition will not be good if we have undersealing applications or undersealing pipe layouts in the bathroom. But yeah, if we have, then as what we can provide as a support to the market is like good material. What we have is HDPE flow drain, and here in this scenario, people use like other materials also like PP or any other materials to have to arrest the value of acoustics within the bathroom. But again, if we talk about a total value in practical scenario, then if we have uh, pipes running under the false ceiling or below the floor, below the slab, then there will not be a much of benefit on acoustic values. But yes, if we have a little bit of good density material, definitely it will give a good value to the acoustic data. Yes, Matthias, if you can add something here.
Yeah, and anyway, that's always, I know this floor drain is a big topic in your region, and we always talk about it. First of all, as I said, the toilet is the most, the loudest one. And then also on the presentation, when I go back here, so you still see my screen, I guess. So
Yes,
here,
yes,
that's what we're talking about, the cross floor, and here you see this installation we consider is partly suitable when we have floor drain. Most important is, as a first step, to put the toilet above. So this is the loudest device, make wall hung toilet to really reduce the noise from the wall, the solid borne sound. And then also the floor drain doesn't have the, let's say, a loud sound, as the flush volumes are very low and in a longer time interval than the toilets, and the impact of the floor drain is very low. And anyway, the bathroom, when the bathroom is below, there are no requirements regarding to sounds in the neighbor's bathroom. So whatever you do there, it's I would say it's not so important. It's more also the neighbor's bathroom which important. And this sound, it's, I would say, maybe if we can say like a rough figure, is half of the toilet, and it's also not considering the diagonal room. So this is partly suitable, depends a bit on the situation. And as Vinit said already here, the material are, let's say, also with thicker material, and there we have also, of course, a better acoustics.
Okay, great. Next one, question from Atik. Mechanical engineers normally follow ASHRAE for noise criteria while designing HVAC system. The noise level you have referring to have relationship to ASHRAE. That's first of it, and I think the next one is that I personally feel ASHRAE values are slightly higher than the values that you're giving, making drainage a bit quieter than HVAC.
Yeah, no, I don't think with HVAC system, and that's also another, let's say, thing. It is not having any relevance because HVAC system also are mostly above the 30 dBA. Mostly what we see in different countries, they are around the 40 dBA, the requirements. And then, of course, you can also ask yourself, does it really make sense to consider the 30 dBA for a piping system when the HVAC system is already on a higher noise level? Also there, you always have to consider the full building. As I said yesterday, the walls, the ceilings, the windows. What is the outside influence? Like we have seen even in the UK regulation, this is already 35 and 40 dBA. And then you can ask yourself, does it make sense to consider the 30 dBA for the building? And if you have a good layout, you use a normal pipe, I think then you already have a good value for the installation.
Okay, good
yeah,
point.
And this is, as we have also in Europe, we don't use, now we use more and more as it gets hotter, HVAC system. That's also something which maybe in your region is a bit different, and you are, let's say, you can be on a higher level with the values.
Okay, great. Next one, question from Iftico. Many organizations claiming for their projects dB range less than 15 dB. Is that possible in a practical way?
As I said before, I don't believe so. What would be interesting? I have not seen that people are measuring afterwards. So as I said, if you get in contact with such offers, just make sure that you have this in written, that they propose this 15 dB. You specify also, is it in the room next to, is it in the room below, is it in the diagonal room or in all the rooms, 15 dBA, that you have this in written, and then you just make a professional measurement afterwards. And I strongly doubt, especially when you do not verify the installation at all times, that you can achieve these values. I think that's very hard to achieve.
All right, great. Next one, again, question from Atik. Do you provide pipe-in-pipe systems? I have a client asking me to give pipe-in-pipe system where the pipe is running in habitable areas. Client think it's helped to prevent both leakages and noise.
Yes, so the pipe-in-pipe system, this is, I know those systems, and those mostly are for very delicate buildings where, for example, electricity or special laboratories where they use this pipe-in-pipe system. But I would say if you use a good pipe material, which is hard to break and very rigid, I think it's not necessary to use such a pipe-in-pipe system. And of course, it would be very expensive. So for the noise, I think it would not have a big influence. It depends more also on the pipe material and on the fittings you use. But of course, on the leakage, it would have a good effect if you make a proper installation. But yeah, we think that the HDP anyway is the best material for installation, and you would not have any leakage with a proper installation.
Okay, good point. Question from Danish. Since you have mentioned that all these tests are done in a laboratory, will it be possible to achieve the same result values on site in different regions?
Yeah, that's a good question. Actually, that's what I doubt very much, that in the region you could achieve these values. As you have seen, you would test the toilet above, so this would be the real situation. Of course, if you would test 5 toilets above and you make the measurements there, or two floors below, maybe you could meet, but this is just an unrealistic situation. And your customer, if he's not happy or the values are not met, he doesn't care if they flush 2 floors above or 1 floor above. He just considered what he's experienced every day, and then he's either happy or not happy. And also the wall thickness, which I showed you, or if they use the wrong brackets, if this is not perfectly applied, you will not reach those values, and those measurements are not of any help.
Okay, I think we don't have any more questions. No, I think we have one last one. Question from DE. Are cast iron pipes better than HDPE or PVC pipes in terms of acoustic point of view of drainage systems?
Yes, very good question. And I repeat myself. I think it doesn't really matter if you use a cast iron pipe or an acoustic pipe. Of course, here we would talk about the DB20 pipe. When we consider to cast iron, I would say it's more or less the same. Of course, it would be better a cast iron and the DB pipe better than PVC or normal HDPE. But still, more important is the layout and the installation. So this is key, and that you consider the full system. So also use wall-hung toilets, decouple the whole installation, not only the pipe from the building, and then you will have good values. between the pipe, I would say the difference, of course, you have non-acoustic pipe, you have acoustic pipe. Acoustic pipes are always better than non-acoustic pipe, but it's in the end, it's also, let's say, a budget, the cost question. Can we afford to do a proper acoustic? If yes, then do it. And as I said, when you do a proper design, maybe you don't even need to use an acoustic pipe in your installation. So pipes, yes, they are important. Acoustic pipes, yes, they are better, but this is just a small part of the whole acoustic package.
Good point. Last question from Danish. Do you have any Revit families for the pipes and fittings, including bracketry, I guess, for the DB system, for the low noise system?
Yes. It's a very good question. So we have, even for Revit, we have our own plugin. So in our own plugin, you have all the families which are on a daily basis. When we do updates and so on, they get updated. So I think it would be good if you get in contact with us. We can show you just the address from Vinit. We can then show you how you can download this, how you can use it. And there you would have all the Revit data, also on a daily actualized basis, and all the features and which are needed in Revit.
All right, great. So I don't think we have any more questions. So if you guys have any question, anyway, you're free to contact Vinit and Mathias directly, by all means. Some of the people are asking for the copy of the presentation. So by all means, drop me an email with your contact details. I'll be more than happy to share the slides later on today. I think, do we have any more questions, or we're all good? Yeah, I think we're okay. So pretty much bang on time, guys. So thank you very much, Vinit and Mathias, to share your insight on acoustic drainage and acoustically, how to make a building less acoustically, in terms of meeting the criteria. So I think we gave us a good insight based on the two modules that you presented yesterday and today. So on my behalf, I would like to thank you very much. And I think we are on end of the session. So thank you very much. Thank you, everyone. Take care.
Thank you so much.
Thank you very much.
Giovanni.
And in case of any question, you can contact